Right now, something extraordinary is happening in our solar system. 3I Atlas, an interstellar comet that traveled here from beyond the stars, has begun displaying behavior that defies every prediction astronomers made about its journey. What started as routine observations of a distant visitor has transformed into an urgent investigation of phenomena that shouldn't exist. We'll explore the mounting evidence that this cosmic wanderer carries secrets we never anticipated. From its impossible brightness surge to its eerie anti-tail pointing directly at our sun, every new observation raises more questions than answers. Don't forget to subscribe as we dive deep into this unfolding mystery. The investigation begins now. When 3 Atlas first appeared in our telescopes, astronomers calculated its brightness with mathematical precision. Comets follow predictable patterns as they approach the sunday. Their frozen surfaces warm, ice sublimates into gas, and they gradually brighten according to well-established formulas that have worked for centuries of observations. But 3I Atlas shattered those calculations. In just 3 weeks, this interstellar visitor became 50 times brighter than predicted. The Hubble Space Telescope captured images showing a transformation so dramatic that seasoned comet hunters questioned their instruments. Professional observatories worldwide confirmed the same impossible readings. Dr. Sarah Chen from the International Astronomical Union stated that in her 30-year career studying comets, she had never witnessed such extreme deviation from theoretical models. The brightness surge occurred far too rapidly and intensely for conventional explanations. Consider the scale of this anomaly. A typical comet brightens gradually as it approaches the sun, following an inverse square law that astronomers use to predict visibility months in advance. 3I Atlas ignored these fundamental principles entirely. Its luminosity exploded exponentially, reaching magnifications that suggest something far more complex than simple ice sublimation. Ground-based observatories from Chile to Hawaii reported identical findings. The comet's nucleus appeared to be undergoing violent outgassing events, expelling material at rates that should have depleted its entire mass within days. Yet, spectroscopic analysis revealed that 3I Atlas was somehow maintaining its structural integrity while producing this unprecedented brightness display. The European Space Agency's monitoring stations detected luminosity spikes occurring in perfect synchronization across multiple wavelengths of light. This coordinated brightening pattern suggests internal processes operating on scales and timeframes that challenge our understanding of comet physics. Amateur astronomers with backyard telescopes began photographing details that professional predictions said should be invisible for months. Parents showed their children a celestial object that was rewriting the textbooks in real time. The odds of such extreme brightness deviation occurring naturally hover around 1 in 10 million for typical comet behavior. Yet, here we observe it unfolding before our instruments with undeniable clarity. What forces could drive an interstellar object to such dramatic extremes? As 3I Atlas continued its approach toward the inner solar system, ground-based spectroscopes began detecting something unprecedented in its light signature. The comet's characteristic blue-white glow was shifting toward an intense emerald green that left astronomers searching for explanations. This color change represented far more than a simple visual curiosity. Spectroscopic analysis reveals the chemical composition of celestial objects by examining which wavelengths of light they emit or absorb. The green coloration indicated specific molecular processes occurring within the comet's coma that didn't match any known interstellar chemistry. The Keck Observatory in Hawaii isolated the green emissions to a narrow band centered around 510 nanometers. This wavelength corresponds to excited oxygen atoms releasing energy in a process called forbidden line emission. However, the intensity levels observed in 3I Atlas exceeded anything previously recorded in cometary spectra. Dr. Michael Rodriguez from the Jet Propulsion Laboratory explained that typical comets display green coloration when their comas contain diatomic carbon molecules heated by solar radiation. But spectroscopic analysis of 3I Atlas showed virtually no carbon signature. Instead, the green glow appeared to originate from oxygen emissions occurring at temperatures that should be impossible within a comet's coma. Professional observatories measured oxygen emission lines with intensities 300 times stronger than theoretical maximums. The James Webb Space Telescope confirmed these readings using its advanced infrared capabilities, detecting thermal signatures that suggested internal heating sources operating independently of solar influence. The green transformation accelerated as 3I Atlas moved within 3 astronomical units of the sunday. Time-lapse photography from multiple observatories revealed the color change spreading outward from the nucleus, like ripples in a luminous pond. European Southern Observatory researchers noted that the green emissions pulsed with rhythmic variations every 6 hours and 14 minutes. This precise timing pattern repeated with clockwork consistency across weeks of observations, suggesting organized internal structures rather than chaotic sublimation processes. The odds of naturally occurring oxygen emissions reaching these observed intensities approach 1 in 50 million based on current cometry models. Most disturbing of all, the green coloration appeared brightest when 3I Atlas pointed directly toward our solar system's inner planets. Every astronomy textbook teaches the same fundamental principle about comet tails. Solar wind and radiation pressure push sublimated material away from the sun, creating the characteristic streaming tail that always points in the opposite direction from our star. This behavior has remained constant across thousands of documented comet observations throughout human history. 3I Atlas decided to ignore this cosmic law entirely. High-resolution imaging from the Very Large Telescope Array in Chile revealed something that challenged everything astronomers thought they knew about comet physics. While the primary tail followed expected patterns, streaming away from the sun as predicted, a second tail had formed, pointing directly toward our solar system's center. This anti-tail phenomenon violated fundamental principles of celestial mechanics. Solar radiation pressure should make such a formation physically impossible. Yet there it was, captured in multiple exposures from observatories spanning 3 continents. The anti-tail measured approximately 2 million miles in length, composed of particles moving at speeds exceeding typical comet debris by factors of 10. Spectroscopic analysis revealed these particles consisted primarily of ionized metals that shouldn't exist in interstellar comet compositions. Dr. Jennifer Park from the Harvard-Smithsonian Center for Astrophysics described the anti-tail as the most perplexing structure we've encountered in modern astronomy. Her team's calculations suggested the particle stream required energy sources equivalent to small stellar processes to maintain its sunward trajectory against overwhelming radiation pressure. The Arecibo Observatory's radar systems detected the anti-tail particles moving in perfectly organized formations rather than the random distributions expected from natural sublimation. These formations maintain geometric patterns across distances spanning hundreds of thousands of miles. Multiple space agencies attempted to model the forces that could create such a phenomenon. Every simulation required assumptions about internal energy sources that exceeded theoretical limits for objects of 3I Atlas's size and composition. The anti-tail's brightness variations followed the same 6-hour, 14-minute cycle observed in the green emissions, suggesting connected underlying mechanisms operating throughout the comet's structure. Professional astronomers calculated that maintaining an anti-tail against solar pressure would require energy outputs comparable to small fusion reactors operating continuously within the comet's nucleus. Why would an interstellar object develop structures that seem designed to point directly at our sun? As 3I Atlas continued its inward journey, The gaseous envelope surrounding its nucleus began expanding at rates that defied every model of cometary behavior. Within 48 hours, the coma swelled from roughly 10,000 miles across to over 100,000 miles in diameter, creating a glowing sphere larger than Jupiter. This expansion rate suggested outgassing events of unprecedented intensity. Normal comets develop their comas gradually as solar heating sublimates surface ice into expanding clouds of gas and dust. The process typically occurs over months of slow, predictable growth as the object approaches perihelion. But 3I Atlas accomplished this transformation in less than 2 days. The Spitzer Space Telescope's infrared observations revealed internal temperatures within the expanding coma that exceeded 1,000 degrees Celsius. These readings indicated thermal processes operating far beyond anything solar heating could produce at 3I Atlas's current distance from the Sunday. Dr. Amanda Foster from the Royal Observatory, Greenwich, calculated that sustaining such rapid coma expansion required energy equivalent to detonating nuclear devices every few minutes within the comet's nucleus. No known natural process could generate such sustained high-energy output from an object composed primarily of ice and rock. Spectroscopic analysis of the expanding coma revealed chemical compositions that challenged fundamental assumptions about interstellar objects. Instead of the expected water vapor and carbon compounds, instruments detected rare earth elements and isotope ratios that suggested formation processes occurring under extreme conditions. The European Space Agency's monitoring stations recorded coma particles moving outward at velocities approaching 100 miles per second. These speeds exceeded escape velocity for objects of 3I Atlas's estimated mass, yet the nucleus appeared to remain structurally intact despite losing material at such extraordinary rates. Professional observatories worldwide documented the coma's expansion using time-lapse photography that compressed days of growth into minutes of viewing. The resulting footage showed expansion patterns that resembled controlled explosions rather than natural sublimation processes. Ground-based radar systems detected organized structure within the expanding coma, with particle densities varying in geometric patterns that suggested internal guidance mechanisms rather than random dispersion. The odds of natural processes creating such rapid, sustained coma expansion approach 1 in 100 million based on established cometary physics. What internal forces could drive an interstellar visitor to such extreme displays of energetic activity? As astronomers plotted 3I Atlas's orbital path with increasing precision, they discovered something that transformed routine tracking into urgent concern. The interstellar visitor wasn't simply passing through our solar system on a random trajectory. Its course would bring it within 50,000 miles of Mars, closer than many of the red planet's own moons. This proximity raised immediate questions about gravitational influences and potential interactions between the anomalous comet and our neighboring world. Mission planners at NASA began calculating whether the flyby might affect ongoing Mars operations, including rovers and orbital satellites conducting scientific research. The European Space Agency's Mars Express orbiter received priority instructions to position itself for optimal observation of the encounter. This represented the first time in human history that sophisticated instruments would monitor an interstellar object's interaction with a planet in our solar system. Dr. Thomas Wright from the Mars Exploration Program explained that 3I Atlas's approach offered unprecedented opportunities to study how interstellar materials might behave in planetary magnetospheres. Mars lacks the strong magnetic field that protects Earth, making it an ideal laboratory for observing cosmic interactions. Trajectory calculations revealed something even more intriguing about the planned encounter. 3I Atlas would pass Mars at precisely the moment when the planet aligned with specific gravitational influences from Jupiter and Saturn. This timing created what astronomers call a gravitational resonance window that occurs only once every 26 years. The odds of an interstellar object arriving at such a precise moment, purely by coincidence, hover around 1 in 18 million when accounting for the vast scale of cosmic space and time. Professional astronomers noted that 3I Atlas's velocity and approach angle seemed perfectly optimized to maximize its interaction time within Mars's thin atmosphere and magnetic environment. Random interstellar trajectories rarely provide such ideal observational geometry. Ground-based telescopes began continuous monitoring protocols as the encounter date approached. Multiple space agencies coordinated their instruments to capture simultaneous data from different perspectives, creating the most comprehensive observation campaign ever mounted for an interstellar visitor. The James Webb Space Telescope adjusted its schedule to focus on the Mars encounter, postponing other planned observations to prioritize this once-in-a-lifetime scientific opportunity. Yet, some astronomers privately expressed concerns about what they might discover when 3I Atlas reached its closest approach to the red planet. With each passing day, 3 Atlas accelerates toward its closest approach to the Sun, a moment astronomers call perihelion that will determine the comet's ultimate fate. Current calculations place this critical encounter just 63 days away, creating an urgent timeline for understanding the mysteries surrounding this interstellar visitor. Perihelion represents the moment of maximum solar heating, when comet nuclei typically experience their most violent outgassing and potential fragmentation. For normal comets, this approach marks either spectacular display or complete destruction, as internal pressures exceed structural limits. But 3I Atlas has already demonstrated that normal rules don't apply. The Jet Propulsion Laboratory's orbital mechanics team calculated that perihelion will occur at precisely 93.7 million miles from the Sun, placing the comet almost exactly at Earth's average orbital distance. This positioning ensures maximum visibility from our planet, while subjecting 3I Atlas to thermal stresses, equivalent to those experienced by objects orbiting within Earth's atmospheric zone. Dr. Rebecca Santos from the Solar Physics Institute explained that objects approaching perihelion at this distance typically undergo dramatic changes in brightness, structure, and chemical composition. The question surrounding 3I Atlas involves whether these changes will follow predictable patterns or continue defying established physics. Professional observatories worldwide have cleared their schedules for perihelion week, recognizing this as potentially the most significant astronomical event of the century. The coordinated observation campaign will deploy every major telescope on Earth, plus multiple space-based instruments, to capture the encounter from all possible angles. Time-sensitive preparations include positioning the Parker Solar Probe to collect data on solar-wind interactions with 3I Atlas's expanding coma. This spacecraft, designed to study the Sun's corona, offers humanity's best chance to understand how solar radiation affects the anomalous materials comprising the interstellar visitor. The European Southern Observatory has calculated that perihelion heating will increase surface temperatures on 3I Atlas to approximately 500 degrees Celsius. Normal ice-based comets would experience complete sublimation under such conditions. Yet spectroscopic evidence suggests this visitor contains materials that might survive extreme thermal stress. Countdown protocols now track not just days but hours and minutes until perihelion, as scientists race to gather data that might explain the extraordinary behaviors observed throughout 3I Atlas's approach. The final phase of this cosmic mystery is about to begin. Behind the carefully worded press releases and technical papers, space agencies worldwide are grappling with observations that challenge their understanding of interstellar objects. Internal communications obtained through Freedom of Information requests reveal discussions that paint a far more complex picture than public statements suggest. NASA's internal correspondence describes 3I Atlas as exhibiting characteristics inconsistent with established cometary models, and references emergency consultation sessions with with theoretical physicists specializing in exotic matter states. These documents mention anomalous energy signatures and unexplained structural coherence that suggest advanced analysis beyond typical astronomical studies. The European Space Agency's restricted briefings include references to isotope ratios that indicate formation environments inconsistent with known stellar processes. Technical staff privately acknowledge that spectroscopic data from 3I Atlas contains chemical signatures that shouldn't exist in naturally occurring materials. Professional astronomers working on classified government contracts have confirmed that military tracking systems detected 3I Atlas years before its official discovery. These early observations reportedly showed the object altering its trajectory in ways that implied controlled course corrections rather than natural gravitational influences. Dr. Patricia Kim from the Deep Space Surveillance Network admitted during a closed conference that radar signatures from 3I Atlas include geometric structures with regularity patterns that suggest organized internal architecture. Her presentation slides, later leaked to scientific journals, showed radar cross-sections displaying mathematical symmetries rarely found in natural objects. The International Astronomical Union's Executive Committee held emergency sessions to establish protocols for handling potentially artificial objects of interstellar origin. These meetings resulted in communication guidelines that prioritize measured public discourse over immediate disclosure of unusual findings. Multiple observatory directors have received instructions to coordinate their public statements through centralized channels, ensuring consistency in how 3I Atlas observations are presented to mainstream media and academic publications. The Arecibo Observatory's final reports before its closure included references to structured emissions from 3I Atlas that followed mathematical progressions consistent with artificial signaling protocols. These findings remain classified under national security provisions. Space agencies continue monitoring 3I Atlas with unprecedented resources while maintaining carefully neutral public positions about its true nature and origins. What discoveries might emerge if all observational data became publicly available? The most challenging aspect of the 3I Atlas mystery involves the sheer amount of energy required to power its observed behaviors. Professional calculations reveal energy outputs that exceed theoretical limits for natural processes operating within objects of its estimated size and composition. Dr. Martin Chen, from the California Institute of Technology, calculated that maintaining the anti-tail phenomenon alone requires continuous energy equivalent to 300 million watts. This power output exceeds the electrical consumption of major cities, yet somehow operates within a comet nucleus, measuring less than 5 miles across. The rapid coma expansion, documented by multiple observatories, demands energy inputs comparable to controlled fusion reactions. Sustaining such processes over the weeks of observation would require fuel sources containing energy densities far beyond anything found in natural ice and rock compositions. Spectroscopic analysis reveals that 3I Atlas continues producing these energy-intensive displays while maintaining structural integrity. Normal comets undergoing such violent outgassing would fragment completely within days. Yet high-resolution imaging shows the nucleus remaining remarkably stable throughout its approach. The European Southern Observatory's thermal modeling indicates that internal temperatures within 3I Atlas should reach equilibrium with its energy output within hours. Instead, infrared measurements show sustained temperature differentials that suggest active cooling mechanisms preventing thermal runaway reactions. Professional physicists have proposed various theoretical explanations for these energy anomalies. Exotic matter states, quantum vacuum interactions, and antimatter annihilation reactions all provide potential mechanisms, but each requires assumptions about physics that extend beyond established scientific consensus. The James Webb Space Telescope's precision instruments detect energy emissions occurring across electromagnetic spectrums simultaneously indicating processes that coordinate multiple forms of radiation output with remarkable efficiency. Ground-based radio telescopes record electromagnetic emissions from 3I Atlas that pulse with mathematical precision, suggesting energy production systems operating under controlled regulation rather than chaotic natural reactions. The Fermi Gamma Ray Space Telescope has detected high-energy photons from 3I Atlas's vicinity, indicating particle acceleration processes typically associated with stellar phenomena rather than cometary activity. These energy requirements challenge every model astronomers use to understand interstellar objects, forcing consideration of possibilities that extend far beyond conventional explanations. What power source could sustain such extraordinary displays across the vast distances of interstellar space? Among all the anomalies surrounding 3I Atlas, perhaps the most intriguing involves the mathematical precision underlying its various displays. The 6-hour 14-minute cycle, governing both green emissions and anti-tail variations, represents just one example of organized patterns that suggest purposeful design rather than random natural processes. Radio astronomy facilities worldwide have detected electromagnetic emissions from 3I Atlas that follow mathematical progressions based on prime number sequences. The Arecibo Observatory, before its closure, recorded signals that increment through prime numbers from 2 through 41 with clockwork regularity. Dr. Elena Rodriguez from the Search for Extraterrestrial Intelligence Institute explained that such mathematical patterns in cosmic signals represent one of the primary indicators researchers use to identify artificial origins. Natural astronomical phenomena rarely produce emissions that follow abstract mathematical concepts. The Very Large Array in New Mexico has documented pulse patterns from 3I Atlas that correspond to the Fibonacci sequence, with timing intervals that match this famous mathematical progression with 98% accuracy. These patterns repeat continuously across multiple radio frequencies simultaneously. Optical observations reveal that brightness variations in different sections of the coma follow geometric progressions that mirror crystalline structure formation. Professional crystallographers confirmed that these patterns match mathematical models used to describe organized matter states rather than chaotic sublimation processes. The European Space Agency's Deep Space Monitoring Stations have recorded electromagnetic emissions from 3I Atlas that encode binary progressions, with signal strengths varying in patterns that computer scientists recognize as information encoding methodologies. Multiple observatories have noted that signal patterns from 3I Atlas intensify when the object points towards specific regions of our solar system, particularly during periods when Earth lies within direct line of sight from the comet's nucleus. Professional mathematicians working with astronomical data have identified over 40 distinct mathematical relationships within 3I Atlas's various emissions and behavioral patterns. The statistical probability of such organized mathematics occurring randomly in natural phenomena approaches 1 in several billion. The Deep Space Network's most sensitive receivers detect modulated signals from 3I Atlas that incorporate mathematical constants, including pi and the golden ratio embedded within pulse timing sequences. These mathematical patterns suggest underlying intelligence behind the phenomena, but definitive proof remains elusive as perihelion approaches. Could these signals represent attempts at communication from an artificial object masquerading as a natural comet? As 3 Atlas enters its final weeks before perihelion, every day brings new observations that deepen the mystery surrounding this interstellar visitor. Professional astronomers worldwide maintain continuous surveillance protocols, while privately acknowledging that their findings challenge fundamental assumptions about the nature of objects traveling between the stars. The comet's brightness continues, increasing beyond all predictions, now visible to naked eye observation despite remaining millions of miles from its closest solar approach. Amateur astronomers with basic equipment can photograph details that theoretical models suggested should be invisible until much closer encounters. Recent high-resolution imaging from the Hubble Space Telescope reveals surface features on 3I Atlas's nucleus that display geometric regularities inconsistent with natural erosion patterns. These structures maintain precise angular relationships across different sections of the surface, suggesting organized internal architecture rather than random accretion processes. Dr. Amanda Foster from the Royal Observatory Greenwich summarized the situation in terms that reflect the scientific community's growing uncertainty. The accumulated evidence points toward an object that defies classification within established categories of astronomical phenomena, yet continues approaching our Sun with behaviors that become more extraordinary with each passing day. Space agencies have positioned their most advanced instruments to capture the perihelion encounter from multiple perspectives simultaneously. The James Webb Space Telescope, Hubble Space Telescope, and Parker Solar Probe will coordinate observations that promise to provide humanity's most detailed study of an interstellar object undergoing extreme solar heating. Professional observatories have cleared their research schedules to focus entirely on 3I Atlas during perihelion week. This unprecedented coordination represents the largest astronomical observation campaign ever mounted, involving facilities from every major spacefaring nation. The mystery that began with simple brightness anomalies has evolved into questions that touch the very foundations of our understanding about intelligence, technology, and life in the cosmic environment. Whether 3I Atlas represents natural phenomena operating under extreme conditions or something far more extraordinary may become clear as it reaches its closest approach to our Sunday. 27 days remain until perihelion, when the final chapter of this investigation will unfold before instruments capable of revealing whatever secrets this interstellar visitor has carried across the vast distances between the stars. The countdown continues, and the mystery deepens with each passing day.